So another equation that you could have gotten for this that's also valid, the slope-intercept form here is y is equal to 4x minus 148. And you can easily move things around in this equation, bring that 124 to the other side, and then distribute this 4, and you'll get this form. So the second part of the problem says that if you've only counted the number of chirps for 15 seconds, how can you predict what temperature it is? We remember that y here is my chirps, and x is the temperature. But y is, it's really chirps per minute, so I really need to change my units. So this unit analysis is probably something you did in chemistry in high school. Let's look at an example here. So y is chirps per minute, but I want to understand the relationship between temperature and chirps per 15 seconds. Kind of awkward, but that's okay. So what I'm going to do is do a little conversion. So chirps per 15 seconds is equal to, all right, chirps per minute, that's what I know, that's my y, times, and now I'm going to use a factor that relates how many 15 seconds are in 1 minute. So I'm going to put my minute up here. So 1 minute. And look, there are 4 15 seconds in 1 minute. Right? So down here I'm going to put 4 times 15 seconds. And now look, let me highlight this in red. On this side of the equation, minutes cancels out, and I'm left with chirps per 15 seconds. The conversion factor is 1/4. Okay, so this tells me that 1/4 times y is equal to chirps per 15 seconds. All right. So what happens when I take this equation, y equals 4x minus 148, and I divide by 4 on both sides? I'll have 1/4 y, that's that chirps per 15 seconds. On the other side, I'll have 1/4 times 4x minus 148. Okay, so let's see here. I'll have 1/4 y is equal to, if I distribute this, I get just x minus, all right, and when you divide 148 by 4, you'll get 37. Okay, so what we see is that if I do 1/4 y plus 37, I get x, and that's temperature. All right, so this is saying that if you know chirps per 15 seconds, so if you've counted the number of chirps that have been made in a 15-second time interval and add 37, you should get the current temperature. Okay, so that second problem is really just kind of rearranging the equation and converting from chirps to minute to chirps per 15 seconds.